You'll learn more about that tomorrow. Jeremy sets up nicely for one of our longtime supporters, Stiles Homag Manufacturing, to talk about some equipment that they are partnership with a European manufacturer to produce CLT products. Chuck Carter, many of you know Chuck. Chuck is a regular fixture at our meetings and has been a terrific supporter of the organization. But Chuck comes up now with Roland Hernandez, two of the leaders there in Stiles as it comes to our CLT manufacturing equipment and also the hardwood product equipment that they make. So they've got some great information for you if you are considering this on a CLT plant or other equipment that they can provide for you. Chuck?
Thank you, Tom. Good morning. My name is Chuck Carter. I've been here a few years now, and Stiles Machinery and myself are very proud to be a sponsor of Appalachian Hardwoods. Today, we're going to talk a little bit about some recent acquisitions of some companies with the Homag Group. The Homag Group has been the ownership of Stiles Machinery since 2014. 2006, the voice of the customers in the U.S. market had asked the ownership of Stiles to bring forth solid wood solutions, and we've done so. And we did that. And last year, we did a little bit more than $500 million in machinery, with 40% of that being solid wood solutions for you guys. So not only do we have, say, molders, rip saws, chop saws, band saws, you name all the solutions, but we also have some mass timber solutions. And if you remember, a few years ago, I had a presentation where I spoke about the expansion of mass timber and how rapidly this was growing worldwide. In 2014, the Homag Group purchased Stiles 100%. So now we are part of the Homag Group based out of Germany. And Homag has continued this by investing and acquiring companies in solid wood. Most recently in 2020, they acquired System TM, which is leaders in automation and scanning with chopping and ripping systems. They purchased Wyman Group, the remaining percent there, which is automated home. And most recently, they purchased a Danish company called Kalasu. Kalasu is a manufacturer of high-end equipment for CLT, glulam, multi-layered panels, as well as post and beams and lamination. So I have invited one of our vertical markets, our mass timber managers here, Mr. Roland Hernandez. He's been in the industry for 30-some years, is absolutely a certified wood scientist. So he can talk at levels that I couldn't even interpret. So I've asked him to speak a little bit about this acquisition of Kalasu and about the magic that that product can bring. Mr. Roland Hernandez.
Thank you, Chuck. So, Jeremy, great presentation. I honestly can say I've never been more excited to follow somebody because I'm going to use, actually, you're going to see some of the same slides Jeremy used. I'm going to give you a picture like looking through a different peephole, almost a different knothole, talking about mass timber. Notice that in the agenda, it talks about Homag acquiring the manufacturer of mass timber. But I also wanted to cater it to this group. So it's the use of hardwoods in mass timber. I'm going to give you a little history. And I also want to put a spin on it that's going to be more of what everyone is interested in, is supplying a factory like that. So let's get started here. And as far as my position, I started with Stiles a year ago. I wish I would have met you, Jeremy, a year ago. What I was covering was Western US, Western Canada. And so I'm actually going to start covering almost all of North America. So yeah, we'll be talking. I like to present it the way I've presented to architects and engineers. The learning objectives. When you walk out of here today, I want you to have a really good picture of what we're going to talk about, which is what are mass timber partners. I'm going to describe that very briefly. And really, what is mass timber? And Jeremy talked about it. I'm going to talk about it some more. And then we're going to talk about how it's made. And then at the end, we're going to actually have a video of a modern factory. So that's what you're going to walk away with a better understanding today. If you go to the Stiles Machinery website, you're going to see that we have solid wood processing equipment. And it's, we have a display back in the back, machinery equipment. Where we really stand out is our service and support. There's actually a 24-hour hotline. We have training and education for all the machinery that comes through our business. Software and digital solutions. Every piece of equipment you get will talk to each other. when we're designing an entire factory for you. And of course, spare parts, rebuilds. And so we cover everything. And again, Stiles Machinery is under the Homag umbrella. Now that we're in the mass timber area, we call it our mass timber machinery partners. As you saw earlier, when you have an entire factory, there's lots of different stages throughout the entire factory. The first two you see on the top left there, System TM, they've been around since 1977. They are handling, they do the lumber handling, finger joining. They too are under the Homag umbrella. And then Caliso RF press technology, they make CLT presses, glue lamp presses. They're a third generation company, and they've been around since 1969. And then they too are now under the Homag umbrella. And as you saw, we have to have several different types of machineries to make an entire factory. We work with Microtech for lumber scanning. They've been around since 1980. And of course, there's planers, sanders, CNC machines, and there's a hand CNC machine down in the lower right there that I'm introducing to the mass timber market, and very interesting features of that machine. But that's our mass timber partners. If we're gonna do an entire factory for you, we have to partner so that all the machinery in that factory is accommodated. So what I want to talk about is, what is mass timber? And it's kind of a little different spin. So mass timber, it's a subcategory of heavy timber construction. So you probably can imagine the stories of the old barn raisings, big timbers, mortise and tenon, old world type of joinery. There's actually a standard that's called heavy timber construction. And what defines that type of construction as heavy timber is beams have to be minimum approximately 6x10s. Columns have to be minimums approximately 6x8. Floor decks less than 3 or 4 inches thick, depending on what type you use. And roof decks not less than 2 or 3 inches thick. So that by definition is heavy timber construction. So if you, for example, a residential home is made out of 2x4s, 3/4 inch plywood, that is light frame construction. And so because of these large dimension structural members, that's the heavy timber, large dimension members, that means that they get assigned a fire rating for the building codes. So in residential, when you have 2x4s and plywood, you have to have that layer of drywall in there or other type of fire resistant features of your light frame. But in heavy timber, just the mass of the timber itself gives it a fire rating. So that is heavy timber construction. And you're probably familiar with some of the other terms like timber framing, heavy timber framing. That's those old barn raising guys, post and beam framing. Those are also subcategories under heavy timber construction. So the main question is, what is mass timber? So mass timber, by definition, is when you utilize these engineered wood products. And there's several products that are considered engineered or mass timber products, but the two we're going to focus on are glue laminated timber, glue lam or GLT as it's being called nowadays. And those are laminated into beams and columns. And then cross laminated timber, which we've been talking about here, is those are panels, and those are for floor, roof, and wall panels. And you can see a 5-6 story building here. This is actually in San Antonio where I live. And it was the first multi-story mass timber building there in San Antonio. But again, as you see there, the elements are glue lam for the beams and columns, and then cross laminated timber for the panels. Here's the maps you've seen before just earlier. And again, now you're looking at it through a different peephole, same information, different peephole. So is the popularity growing? And Jeremy just established that. Yes, it is. And this is the projects on record. So there's 1,860 projects, and this is fresh. This is as of June 2023. And all these dots here, they represent that the construction has started, construction has completed, or it's in design. And if you look at the two arrows on the bottom right there, construction started or built, the majority of those projects involve CLT. So that shows you the popularity that it's CLT is really dominating this movement. In design, I want to point out, and on my site here, 444 are construction started. That's in the last 20 years approximately. And in design, there is, what is it, 580 something? I can't see that far. But so the point there is, there's more in design right now, as of June 2023, than the total that has been constructed in the last 20 years. So Jeremy showed you the next one. It's the animation of all these projects that are developing. So again, and now here it's what's been constructed. Under that other view, like through another knot hole, is that arrow points to when PRG 320 was adopted. So notice that the initial first decade or so was, folks were doing full engineering of buildings. They were getting them approved at the local level. And you can see that pretty much a linear line, it's kind of like trying to get it, trying to gain momentum. But once that PRG 320 standard was adopted, you can see it's exponential. And again, this is constructed. So that total there, that's 444 at the top of that exponential curve. And right now, today, or as of June 2023, there's more projects than there are ever constructed in the past 20 years. So the point is the popularity is there, and we don't see it slowing down right now. And the way to even confirm that for the next decade is that you look at Europe, and they're still on an upward rise. And Europe is at least a decade ahead of us in technology and in fabrication of these projects. So if we look to Europe as a 10-year foresee of the future, we're not seeing any slowdown. So, and of course, Jeremy circled the Appalachian area, lots of opportunity. So same slide, under the mass timber construction. So why is this so popular? Designers, and I want to add, and developers love wood as that it's a renewable resource. Every developer wants to put that LEED Platinum stamp on the front door of their building. And so wood is this in this green movement. There's less greenhouse gas emissions to produce glulam and CLT versus steel and concrete. So how do we affect that map that we just saw? How do we affect that popularity to say, I want to promote hardwoods? It boils down to convincing the designers, the architects and engineers, and the developers to say, not only do I want a mass timber building, but I want to make it out of hardwood. And the way to approach those folks is the architects are always open to listen to new products. It's called AIA presentations. And so I've done that for many years, where I go and promote glulam and mass timber. And so, by the way, my previous employer was one of the glulam manufacturers. So I was in the project managing. So I actually was project managing projects that would involve the fabrication and delivery and install of these projects. So you got to hit the designers and the developers and convince them to call for hardwood glulam or hardwood CLT. The other reason they love it is like the guys up in the upper right there, fast install and minimal job site waste. You're not going to have a pile of rubble. There's no sawing that goes on at these job sites. Everything comes pre-finished, pre-machined, and ready to fit. Steel connections go together, so everything comes ready to assemble. So minimal job site waste, and of course the beauty of wood. So you see there in the lower right, exposed wood elements, and again, these are fire rated, so you don't have to go put a drywall surface on that for getting its fire rating. It has its fire rating all due to the mass of the material. And everybody's heard of a tree hugger, right? Nobody's ever heard of a steel I-beam hugger or a concrete column hugger. There are wood glulam huggers in mass timber. So this column here was in the tallest mass timber building in the world. It's actually in Milwaukee, Wisconsin, 25 stories, and that column that I was hugging there, that's the bottom floor of that building, the bottom timber floor. I asked the developer of this building, what led you to go to, they actually use European CLT and European glulam for this. And his one and only answer was only those two companies could supply a project of this size. So production was key in choosing the supplier of that project. When I sit down with folks that are interested in setting up a factory, I ask them, and I show them this picture, what market are you trying to supply? Are you trying to supply projects of this size? Are you trying to supply projects of the 4 to 6 story, like the other picture I showed you? Are you looking to do just 1-story banks or large glulam natatoriums? So we got to get a definition of what is the objective of that factory before we say let's talk about a factory. So but that's like at the top of the heap there is the supplying volumes of that level. So let's talk a little bit about the glulam and CLT manufacturing. And I found these two photos on the internet. I think I know that the top glulam example was adhesive manufacturers, because notice that they really are highlighting the adhesives. But in general, and just in general, concept-wise, glulam, you're taking lumber, and if you're going to make beams that are larger than the lumber you've got, then you're finger joining them end to end to whatever length you need. And then you take those long length laminations and you're gluing them up face to face into a beam, like what you see there. Plain concept. Cross-laminated timber, same concept. You're still taking lumber, finger joining it end to end, but now you're laminating it in, 90 degrees to each other. So there's longitudinal and transverse laminations, kind of like plywood, except plywood is veneer. Here you're just laminating lumber. A point that I'm going to bring up later, notice that this lower CLT graphic, I think I borrowed that from the Sterling website, is notice that they show nice S4S same width lumber. Of course, everyone here in the room, processes random width lumber for hardwoods, right? So you see this as an opportunity, but also a challenge is that row that's going across the width there, you can actually utilize random width. There's nothing in the standards that prevents you from doing that, and you can increase your yields. You don't have to take your random width lumber and rip it to some even width and then lose yield immediately. So there's actually opportunities for use random width in this product. But there's challenges to processing that, but we'll talk about that. So glulam, let's talk about glulam. And here's where I say it's part of the history. We've seen it in history, and we're repeating history. We're making history right now. So let's talk about glulam. So the main point about all this mass timber, and we're here with hardwoods, we're actually targeting to make an engineered wood product. So we're not just machining lumber to a shape. We're actually making an engineered wood product, and it's going to be used in a structural application, like that 25-story building we just showed. So for that reason, because you're making a structural product, you have to follow a product standard. And for glulam, it's the ANSI A190.1. And in that's like your quality control standard, that if you're going to make a structural product, you better make sure that you're meeting the requirements for lumber, the grades, laminations, how they're all fabricated, the finger joining, for example. What adhesives are you going to use? They better meet all the quality control testing, and then the bond quality. So there's in that picture there, you're going to have face bonds, you're going to have edge bonds, you're going to have end joints, the finger joints. So all of that is quality control, and you're going to have to develop a quality control manual, and you're going to be inspected. So there's daily quality control that you do in-house, and you're going to have inspectors coming in to make sure that you're operating not just at a required level, but also consistently throughout the year. So that brings up my another slide that I share when folks come to talk to me, is that if you're going to become a certified manufacturer of glulam or CLT, you need to meet you're going to need to meet with these certification agencies. And the one that I highlight is APA, the Engineered Wood Association. I actually work there. And so AP is going to put you through a series of questions. Now, what wood species do you plan to process? Hardwoods, right? What layups do you plan to produce? Well, we have to talk about what's in the standard. Who will be your lumber suppliers? And so in this case, you all are the lumber suppliers. So APA wants to make sure that you're going to have a consistent supply. They don't want you to always be struggling to find a resource, and then your product is not going to be consistent. Who will be your internal lumber graders? And here again, this is a structural product. So we're not talking about your NHLA grader. We're talking about structural grades. And then what adhesives will you use? Well, that depends on what type of process you're going to be pressing these or finger joining, and different adhesives have different performances. So that's important for the hardwoods here again, and many more questions. So you see these factories, layouts, and you also have to have a whole other QC lab in that factory, because you're going to have to do daily sampling of finger joints. You got to test them in tension in-house. You're going to have kilns for processing your shear blocks to test your adhesives for strength and for durability. So you're going to have a whole QC lab in-house for that. And so that's typically not talked about. So that's the kind of questions I go through when somebody's looking to do this. And all of this leads to your daily quality control manual. So APA is going to want you to develop a quality control manual. So you say, this is what I'm going to be doing daily and throughout to make sure that I'm maintaining the strength quality and consistent quality. This is an important slide here. I created this. So when I first started with Stiles, I said, let me make a map of all the certified manufacturers. And green was me. That's why Jeremy, that's why we never met, because I was green for this whole first year, but I'm going to start visiting all the reds as well. And so these are all the certified manufacturers, and certified meaning for structural. So you showed a slide of that was in the mass timber manual that got put out recently, and there was 18 manufacturers. I think 6 or 7 of those are like Sterling Structures. They have 2 plants, Texas CLT. So they're producing crane mats. Structure Craft was on that list. They produce Dow laminated timber. So they're not on here. This is Glulam and CLT. So if for the CLT group, I think there's only 11 manufacturers that are making CLT. Those others are making CLT, but they're not certified for commercial, like the building that you showed. They're not even certified. They're just making crane mats, for example. So this is the map I produced just to kind of give you an idea. And we've talked about regions, right? Appalachia is right there. If you're going to want to convince one of these manufacturers to receive your material, they got to go through those series of questions, even though they're already certified. If they want to introduce a new species, they're going to have to go through all that series of questions and certification. So it's a hurdle to bring a hardwood in, even to an existing plant. Okay, so you have that QC standard. So that's just say, how do you operate your factory? But then you need to know, well, what am I going to lay up? So in Glulam, and I'm showing you the Southern Pine. This is probably the most common layup east of the Rockies, is a Southern Pine 24F V3. And again, notice the circle that says that's the softwood standard, and it's 2020. So what you see in that table is how you get it in that standard. But I drew up that cross section. So this is the picture I want you to have in your mind. It's a cross section of a Glulam, and if I want to make the 24F V3, this is like the recipe. So 5% number 1 dense, 15% number 2 dense, the core of number 2. So you see the picture. That's the recipe, and then it has to have this special tension lam on the bottom 5%. And so if you have like a 20 lam beam, that's the bottom 1 lam. If you have a 21 lam beam, 5% is more. So you're gonna have to have 2 tension lams on a 21 lam beam and higher. But anyway, it's the recipe, and the way I like to say it is, if you follow the recipe as a certified factory, you're then going to be able to assign a design value. So this 24F V3. It's called a 24F because it's got a design bending strength of 2,400 PSI and 1.8 million PSI of design bending stiffness. So those 2 numbers and more design values are what the engineers jump in and use so that they can design beams for their large building design, so that they can size those glue lamps. So follow the recipe at the factory, you produce a product, and there's design values associated with it. That's how this is all set up in mass timber. Notice that I threw some numbers in the corner there, specific gravity. So basically the density. Southern pine and Douglas fir are the 2 most common species used for glulam in US. And then also spruce pine fir and hem fir are used in CLT. So I'm keeping those specific gravities on the picture there because we're going to come back to that. So 0.55 to 0.43. Oh, and by the way, and it's still there, by the way, that 25-story building that I showed you that was made with European spruce has a specific gravity of 0.37. So that 17 stories of mass timber was made with a wood in Europe that has lower specific gravity than what we have here in the US. So, and I think it's 0.37. So I think you can write that down. So hardwoods, what about hardwood glulam? And here's where we start getting into some history. Back before this 1996 version, notice that it says 96, and this is by the American Institute of Timber Construction. There are hardwood glulam layups in the standards. It's not by APA, it's by AITC. And the way they set up is they call it by groups, group A, B, C, D. And there's a lot of species within each group. So the group A, and I pick on red oak for a reason, I'll show you why. Red oak is a 0.62 specific gravity. So even much higher than southern pine, and we all have a feel for that. Other species that are in there like ash and hickory. Group B, red maple, I'm picking on that one for a reason, 0.54. That's actually a similar, and these are textbook specific gravities. The 0.54 for red maple, soft maple, is right at about the same as southern pine, a little higher than Douglas fir. And then yellow poplar. So everything we've been talking about is yellow poplar here. That's a group C species in hardwoods. And notice that it's a 0.43, and again, textbook value. And notice that it's in about the same ballpark as spruce pine fir and hem fir. And we're going to latch on to that information right there. So Group C yellow poplar is at about the same level as spruce pine fir and hem fir. There's a lot of CLT being produced today that's made out of hem fir and spruce pine fir. So there's a good starting point there. So the strongest visually graded yellow poplar in that standard, 1996, well, that's actually today's standard, but it's that old, is a 14F V1. Remember that Southern pine was 24F. Well, this is the strongest available for visual grading. 25% select structural on the bottom, 25% number one, and then number two in the middle. And it still needs that even higher grade tension lamb. And even though you used all this great high quality and expensive material, you can only assign it a 14F and a 1.3 million. That Southern pine was 2,400 and 1.8. And again, these are structural joist and planks grades. So do you think this is going to fly? I mean, that is, you're using up expensive FAS grade material to make a structural product that can't even compete with a Southern pine. So that's how the standard was. And so back in the mid-90s, and by the way, I also worked at the Forest Service. Oh, and by the way, I am on the PRG 320 committee, Tom. So I was on that email list that just came out actually while we were talking. In the 90s, and when I worked with the Forest Service, we said this hardwood glulam standard is very conservative. Let's make up some layups. And so these are some of my reports here: efficient utilization of red maple, yellow poplar glulam performance, and so we said, let's go make hardwood glulam layups made from mechanically graded lumber. So you don't have to use select structural, you don't have to use number one. Let's take material and run it through a mechanical test program, come up with some grades, and see where we are. We actually had a target. And the reason I picked red oak, red maple, and yellow poplar is because that's what we studied: red oak, red maple, yellow poplar. So I was in a different life, was one of the researchers doing that, kind of what's happening today, right? And so the mid-90s, I'm going to refer back to that one on the left, that picture. That picture is worth 1,000 words. Because one of the things we wanted to do is, like, it doesn't make sense to cut up your FAS material and propose a glulam made from high grade, because that's higher valued in another industry, in the hardwood and furniture making. But the objective of that study was to say, let's use that center cant. After all the high grade material has been processed out, let's see if we can use that center cant and make an E-rated grade. So that, like I said, that picture is worth 1,000 words. So the feather for a researcher's cap was that those three line items are now in the standard to this day in 1996. So yellow poplar, red maple, red oak, group A, B, C, D. I mean, A, B, C. And this is what it looks like. So again, the other feather for the cap is that we came up with a layup that targets 2,400 PSI and 1.8, just like a Southern pine. And if you look at percentage increases, that's like 72% stronger than what was available before with visually graded, and 38% stronger than that 1.3 layup that was all visually graded. And so again, it's in the standards. But you know, are you seeing, this is 1996, are you seeing that in use today? You know, and I think back then there was more about doing the technical feasibility. So a lot of the research going on is always about technical feasibility. And then you all here in the audience, you're interested in the economic feasibility, right? So how do you use your material? So that's still a hurdle that needs to be overcome. We saw, you know, we don't want to repeat history and see this 20 years from now. Actually, is that 30 years from now? And in 30 years from now, we don't want to see CLT in the standards, but nobody's using it. So we got to do something to not repeat history and say that we're going to use hardwoods in CLT. And I'll tell you, and I'm going to show you about how there's advantages for CLT as opposed to glulam. Okay, I'm not going to go into that long spiel about like I did for glulam, because I was covering some history, but CLT, it's exactly the same parallel. It's an engineered wood product, and that's going to be used in a structural application. And everything's exactly the same as far as requirements for quality control, bond quality. The inspection program got to get certified by APA, but it's now the ANSI APA PRG 320 standard. So that is the standard for CLT, and you saw the other one that was for glulam. In that standard, there's an Annex A. That's like the recipe page. It's not a different standard. It's a recipe page. And so if you look at there's I think it's the V2 that is the number one spruce pine fir on the long longitudinal layers, and number two spruce pine fir on the transverse. So that's the recipe. If you use number one and number two spruce pine fir, you are assigned a design value. Well, as of like right now, like there was literally a email that just came through like during the first talk today. The PRG 320 is going to be adopted. And I guess there is voting still to go on, but that layup is going to be called a VH1. H is for hardwoods, and it's yellow poplar. So the other hardwoods are not in there yet, but yellow poplar will be in there likely, right, after the voting. And I think the target date is late 2023. The printed might actually say 2024, but that's happening right now. And does that sound familiar? All this research going on to get hardwoods in the standard for CLT. 27 years ago, we were doing exactly the same thing to get hardwood glulam into the standard. So let's learn a little bit from history. The VH1 layup is actually kind of nice because it's easy. Number two, every which way. So number two longitudinal, number two transverse. And again, this is number two structural joist and plank. It's not too common appearance grade. So there's going to need to be some regrading going on here. And we're going to talk about that. So I pause here, with this picture, and imagine you're producing random width lumber, and everyone is. To make that glulam on the top, you're going to need to do some width sorting, and if you have a target glulam width, you're going to have some yield loss because you're going to need to trim some boards. You're going to have to plane that final beam, and there's already a yield loss that puts you already in an advantage just to make it. We haven't even talked about the pricing and everything. In CLT, all those nice equal width boards that are going across there, that actually can be random width. So you will need to S4S, but you can actually utilize multiple different widths across that layer and across the length, so to fill up that volume. So I think there's a small advantage here to try to overcome some of that cost difference by using the full width of random width. So there's just a tidbit there. I wanted to pause there on that. Machinery wise, we're actually in discussions with designing a machine for that. So don't ask me today, but ask me later. So let's go through about how it's made. And I really want to relate it to what do you need to know as it relates to hardwoods, right? So let's make some hardwood CLT. And this is a hypothetical sit down on how we're going to use yellow poplar. So you want to make yellow poplar CLT. Well, the PRG 320 has adopted this new layup. It's called the VH1. So that means that we need to lay up number two grade yellow poplar, and it's number two grade structural joist and plank. So you as the suppliers, you want to utilize number two common appearance grade. Maybe you can utilize your number three common. That's a question, right? So what does that mean? You're going to need to regrade cost effectively. So, and I'm not talking about your NHLA grader that is grading your appearance grades. And now we got to get him to rerun everything that he just graded and make it see what falls into number two grade structural. I want to show you some cost effectively. We'll need to process. We want to process out what is true number two structural out of that material we're supplying, and then maybe we know there's going to be reject that does not make number two structural. How can we upgrade that and all those reject sections, and maybe we can reintroduce it. That layer that you saw building in the transverse layer of a CLT, there's a lot of leeway in those cross layers to use lower grade or reprocessed materials. So that's where CLT is an advantage. And maybe that's why history shows that the glulam was not easily adopted. So next line is we're going to make longitudinal lambs and transverse lambs. And then we're going to produce the CLT. You got to press it. Then we got to sand it. And we want to get it out to the job site. So we got to do CNC with the final product and get all the details so that it gets installed out in the field. So let's go through a factory here. So we call this a compact factory. And this factory is on the Kalamazoo website. So we call it a compact CLT factory. But I'm going to do on the lower right is kind of show you some of the different features along that whole line. So you got your lumber and feed, obviously. So System TM produces what they call their OptiFeed series. You can go as simple as a tilt hoist to bring in your material. Notice that I put a square around the bundles of lumber and a forklift feeding it. Or you can get it even more advanced, and there's what's called the OptiFeed 6000 VAC. We'll have a video later So basically you're pulling off whole rows of lumber and you can feed in the system at 32 boards a minute. So actually a very high speed line that can be just the infeed. Next, we use Microtech here to do lumber scanning. So before you run a board through your finger joiner, if you have a warped board that's twisted and crooked and bowed, that's going to just jam up your finger joiner, and then you're spending hundreds of dollars a minute to try to get that unjammed and your production stopped. So what Microtech does is they have what's called a curve scan. So they map out the curve or the warp on a board, and if there's something that's out of tolerance, they send the software signal to a crosscut that I'll show you in a bit, and it chops it up. So say that's warped, bad for laminating, and let's process it down, and we get it in a shape and form that we can refinger join that or completely reject it. So that's curve scan. So this whole area that I have boxed there, that's curve scan. There's also moisture scanning. If the moisture's too high, that's where it gets kicked out, sent to a secondary drying facility. So everything there is happening there. Then it gets sent through a golden eye. So lumber scanning, X-ray knots. So you're X-raying, and imagine your NHLA guy that's grading, and I go like this because I know they walk on the boards and they're walking down the line. So they flip the boards, and you know he's looking at knots as well. Well, this machine is looking at knots. It does it at several hundred feet per minute, and it's not only taking an X-ray of every single knot, but you have a program that runs this. And if your program says, I'm just sorting number 3 grade lumber, well, guess what? That board is just going to zip right through and nothing's going to happen to it. But if you want to say, I want to sort out FAS, for example, we're still talking appearance. I want to sort out FAS. So every board that has 6 foot minimum, is that still the grade 6 foot minimum for FAS clears? The program will say, okay, if there's a 6 foot board, send the software and send it to the chop saw to cut out every clear out of there, because that has a higher value. But for structural, we just need number 2 for our yellow poplar, CLT grade. So if it meets number 2 at a certain length, chop it and send it to the number 2 grade. If it's reject, let's go do something about that. So that's what this all can do. It's not just the scanning of it, but it's the software that controls every machine down the line. All right, so now you got lumber processing. So here's the System TM OptiCap series. I had to look it up, but they run at about 400 plus feet per minute. And it's not just, when it runs through, notice all those chops that are to the right there. So it's chopping at 400 feet a minute, and it's chopping little clears, the full length 6, and all that information it gets from that knot map. It's doing a smart cut and all those different sorts. So in this case, you see about 9 sorts and maybe a reject run. So that's what this system does with run it through the golden eye, OptiCap, chop it, and you've got all your sorts that you're ready to send it to higher value furniture hardwood, or send it back through the line for the low grade transverse, or move it to the longitudinal grade, right? So that's key, those 2 last steps there. So now you have it all processed. Let's take our reject and send it right back down that line. And let's take it to the short board finger joiner. So suppose there's pieces that were too warped as an 8-footer or 10-footer. We chop it down to clears, and we have what's called the System TM OptiJoint H200. So that's a short board finger joiner, and you'll see it in the video. So we can't zoom in here, but taking boards that are short, finger join them with a horizontal joint, and that's going to then make. And what we're doing here is let's just make the 10-foot wide or 12-foot wide CLT transverse lamps. So we're just finger jointed shorts, making only for the transverse, and we're going to send it to the outfeed here. So here's finger jointed boards that had just been finger jointed, and they're just made from short boards. They're going to be hidden in that CLT layer. That's the outfeed on the left. We're going to take those and take them to the infeed over on the right, and that's going to be the infeed for your CLT. So while that's happening, all those higher grade or long boards that got sorted out, we're going to send them to the long board finger joiner. And so in there, the infeed for that is that OptiFeed 6000 vac. So here we're only doing 1 grade, number 2, but suppose you had multiple grades like that glue lamp that I showed you that had 4 different grades. Here you can be picking off from 4 different packs and saying, I got to send 5% number 1 dense. I got to send 10% number 2 dense. I got to grab 50% number 2 medium. And imagine the log jam if you had a human having to do all that. Well, here you got a machine that's just pulling exactly like that recipe. So now I'm circling back and using some of the terms you just learned. We're grabbing the recipe and feeding it into the finger joiner. And we're going to have all the material that we need to make up the beam, or in this case, to make up the CLT. System TM also makes a long board finger joiner. So here you're taking long board. Suppose that board you ran through is perfect number 2 grade structural as a 10-footer. Well, that never got chopped. It just gets sent to the long board finger joiner. So these long board finger joiner can handle from 6 to 20-foot lumber. So it goes through, and now you have your long lambs. So if you're making 40, 60-foot glue lamb or CLT, you're making the 40 or 60-foot lambs. Here's the assembly area. And we're only talking CLT here. So here's where Caliso machinery comes in. So not only do they do the radio frequency presses or the radio frequency tunnels for the finger joiners, but they also do the system solutions. You know, where are you going to stack your long lambs and where are you going to stack your transverse lambs? So they design all the in-feed and out-feed of these presses. And then you got the press. So here is a radio frequency CLT press. They make glue lamb presses, and they make CLT presses. They also make a combi press, which will make a glue lamb and a CLT in the same machine. The limitation is that glue lamb is limited to about a 1.2 meter, which is roughly 50 inches or so. So your CLT is limited to that. So most folks being architects, engineers, designers, they're designing here in the US with 8, 10, and 12-foot CLT. So that machine doesn't work if you're going to want to make 8, 10, or 12-foot wide CLT. But it's a combi press. If somebody wants to get introductory into this CLT business, you know, you can make a slightly wider than a 4-foot CLT, but you can make a standard size glue lamb. So that's presses. You made a press, you sand this. If you're a architectural intent, like those buildings we saw, then you want to sand it with a sanders. This is one of our partners. If you're going to make crane mats, you can skip this step. You don't even have to get that piece of machinery if you're going to be making crane mats. After you have a finished product, as far as sanding, you still got to process edges and maybe cut out doors and window cutouts and door cutouts. And that's when you get to the CLT panel. And we are partnered. We have partnered since 1987 with a company named Han CNC. They make a tremendous, look at the size of the guy there standing next to it. They make a CNC that has the width capacity of a CLT panel, but it has the complexity of end cuts for beams. So you see there's like a ring thing looking there. That's actually a 1 meter long drill bit. Most other manufacturers of CNC for beams, they make a 15-inch max. This is a 1 meter bit, and I imagine it doesn't go all the way into the 1 meter, but so they have an end tie run out. So they kind of, if you're going to drill 1 meter, you better support that tip and go in. And that's what that is right there. So a very significant feature that can be used both for beams and CLT and all in one. The other manufacturers, they will make a beam CNC and offer that, and then a CLT CNC and offer that. The beam CNC can't do the width of a CLT CNC, and the CLT CNC can't do the details of a beam CNC. This is combined, so we're really excited about this product. So that looked like a real nice drawing. That's actually a real factory. So we're going to go see a video here, and I'm going to talk to it because everything I just showed you, you're going to see it now, and you've pictured it in a drawing. Let's look at that. So I'm saying my thank yous here because I'm going to exit this PowerPoint show, and then we're going to run the video. So no questions yet. We're going to run a video. It's going to be about 4 minutes. Do I do anything here to turn it off? So the nice drawing was actually a real factory. It was when it starts, it's in Austria. And again, System TM, Caliso, Microtech, Stiles. You're going to see the logos on there. That's our promotions. So LOC is the name of the company. They they have the, like I mentioned, the system TM, Caliso. So here you see okay, so there are stickers being brushed off. In feed is those whole layers of lumber are being brought in. You see those red lines there? That's laser scanners that are doing the curb scan. This one, they're big in Europe about making sure that all your annual rings are oriented the same way. Here is the OptiCap. So you're going to go through and notice here's where it's 400 feet per minute. You're going to see an upper. Here's a GoldenEye scanning all the knots, all software driven. So here's the OptiCap. Notice the board coming in on the right, and it's getting cut up. And then all those sorts, you saw, I think it was 9 sorts in the drawing. That's them right here. So, and if you're imagining the 2 common hard yellow poplar being processed into number 2 structural, imagine all your sorts. Those were your longs. You're going to have short rejects. So suppose these are the rejects, like they don't make number 2 common. So they get chopped up into clears and they get sent right back to the short board finger joiner. Here's a short board finger joiner. This is a horizontal joint where the finger joint's shown on the edge of the lumber. And all these are going to be doing is they're going to be re-finger jointed back into, that was the OptiJoint H200 is short board. They're going to just be made into the 10 footers or 12 footers, but the transverse layers. At this stage, we recommend radio frequency curing. If you radio frequency cure, that strength of that joint is about 75 to 80% of its strength immediately coming out of the machine. If you don't use radio frequency, then you're relying on time for that joint to cure. And there's a lot of handling going on here in a factory that could potentially stress that joint. So now we're up to the long finger joiner. I missed some of that. So now we're up to the long finger joiner. There's the crusher. That board there is going off to the other end of the factory. And at that point, notice all that movement. That should be radio frequency cured. These are the long lambs that are going into a layup area. And then the Caliso system solution is that you got to take your long lambs and then you got to bring in your transverse lambs and start laying them up. So here comes the long lambs. Remember, they have to bring in those 8, 10, or 12 foot wide transverse lambs from that other area. So they bring them around, and this is a glue application. UIST is one of the suppliers of that. So here's the transverse lamps being brought in. This is all in that kind of same area, assembly area I showed earlier. They are being S4S'd because that layer, all those boards should have good contact between the edges. And here's where you're doing the edge glue application. So again, these are the transverse layers coming in. And so if you're making 10 or 12 foot wide CLT, that machine there is handling 10 or 12 foot wide boards. So it's only for the transverse layer. Edge gluing going on here. And all of this is going to reach you're going to see a little regular frequency cure here a little bit with the light going on. I think this is not a full cure. It's just to take it from here to the assembly area. So now you got to assemble the long layers. You got to do the transverse layer. That's a whole system there. And then getting it ready to go into the press. There it goes into the press. Notice look at the left edge that's going to get pressed, and you're going to see the squeezing. Look at the left edge. Right there, boom, it gets squeezed. And then these presses that are radio frequency, those are only pressing 20 feet at a time. So it's a continuous press. So if you're making 40 foot CLT, you do 20 feet, you move it down, you do 40 feet. If you're making 120 foot CLT, nobody's doing that. You do that 6 times. So you theoretically can go out the door and enter the parking lot, but of course, trucking is the limitation, right? But the continuous press is the same size, whether you want to make 20 foot panels, if you want to make 10 foot panels, or if you want to make 60 foot panels. It's the same press, you're just cycling. And because of that radio frequency curing during that 20 feet, that means there's certain adhesives you have to use. MUF is one that's used. You can also radio frequency cure PRF, which is like the gold standard for adhesives as far as what's been used for many decades. So that's, I hope you saw there through the system. I hope you had a real clear image of because sometimes you see these videos and you're just like looking at a peephole and what's going on here in front of me. But talking through it after just seeing that drawing, I hope that really let you follow along. But Actually, that's it. So that's the video I wanted to show. I hope you learn. I don't have my four topics there, but I hope you learn a little more about what is mass timber. I hope I built upon what you presented, Jeremy. And then as far as what it takes to, there's going to be certification hurdles, and we're here to do that. I mean, like I said, I work for APA. I work for the Forest Service. Those studies I did, I was actually on the committees that was voting on the Wood Innovation Grant types of projects. So I've been like Johnny Cash. I've been around, and so anyway, if there's any questions you have regarding machinery, mass timber certification, and I get like my title says, vertical market, anything and everything to do about mass timber. That's what I'm here for. Yes, Silas. There's some questions asked earlier that I hope you re-ask them, because I had some thoughts on that.
Thank you so much for the wonderful presentation. My question is, when I visit the CLT mill across the US, one of the problem is with the tolerance of that lumber, right? Some of the supplier gives you 1 extra inch, some of them half extra inch, some of them give you 2 inch extra, and that is true for the hardwood as well. So how your machinery just adjust or address those issues, because most of the finger joint are set up for a very fixed length, let's say 8-feet, 10-feet, 12-feet, right? One question is that, and the second question is that for the finger joint, there is always the issue with the edge end defect, like that hole knots or something on the end. So how those things are just addressed by the machinery that you just saw us. Thank you.
Okay, so in the standards, there are specific statements about the defect at the end of a board that will affect the finger joint strength, and it's in terms of knot diameters from the end. So the golden eye and the AptoCap, that can all be handled by software. So if you say, I detected a knot and I want to put a finger joint in this area, you can program in the software that I want to stay 3 diameters away and I need to cut here. And that's handled by the GoldenEye scan and by the AptoCap chop. It's all the instructions. And as you saw it at 400 feet per minute, that can be done. And so you're basically just programming, not you, the factory. It's the machinery supplier and the software supplier will come in and set up. I want to take 2 common. I want to grade out number 2 grade structural, and I wanted to follow every detail of the PRG 320, like stay 3 knot diameters away from the end so that my finger joint has the strength it needs. And that's all done by software at the production speeds you saw. Your other question was about thickness. I didn't hear that. You got the microphone.
So my question is that if there is a defect in the end joint, how your machinery will address that one? And the second thing is there is a tolerance, like if you buy a lumber from somebody, some different supplier, some of them has the extra ½ inches, some of them has the extra 1 inch, or some of them provide extra 2 inches. And if you just want to use that lumber in your system, you have to trim it, right? Otherwise you cannot use the finger joint. So I just want to know how your machinery that you introduce here will address that problem without just chopping them. If they have the ability to address that problem, or they again do the chopping, so the trimming, and then make a uniform length of certain, like 8 feet, 10 feet, and 12 feet, and go for the finger joint.
Yeah, no. So there is no. So when it runs through that GoldenEye, not only is it getting a map of knots and all the defects and making, recording what was going to be a later decision in your software to do grading, but it's also measuring the length. So if you have a 12.3 foot long board and the end is perfect, like perfectly clear wood and no end splits or checks, it's going to detect that and it's going to say just finger joint it as a 12.3 foot board. And if the next, you all run random width, random length, if the next board is 5.2 feet long and it's all reject or warped or something, it's going to say, keep that one and just finger join the ends because it's fine. But this one that needs to be chopped up in the AptoCap because the GoldenEye determined that. So random width, random length is going to be captured and mapped in the GoldenEye and all these other scanning equipment. So they read everything on that board, including length, width, and thickness. I thought your question was about thickness, and so lumber will have to be S4S, and so that all your layers are the same thickness, and then so that you have good edge bonding between the boards. But I did mention that here's an opportunity to utilize random width. And in September, I'm going to be sitting down with one of the equipment manufacturers to come up with don't write this down, but we're going to determine if it's technically feasible. Can we have an adjusting width planer so that if you're running random width, of course, you're not going to run a 8-inch wide and a 4-inch wide, and both are going to get S4S. You might still have to do width sorting, but if you say everything within an inch, that edge S4Sing might adjust to be addressed later. So I'm sitting with a machinery manufacturer to come up with something that would actually be very applicable to the hardwood suppliers for this CLT endeavor.